In this video, I'm going to show you how to set up your calculator for use with statics. I strongly recommend using either a TI-89 or a nSpire calculator. There may be some other calculators out there that work well with vectors, but these are two that I'm familiar with, and both of these calculators are set up very, very well to work with vectors both in 2D and in 3D, plus to be able to do all the other mathematical operations that we typically do in statics. And frankly, they make a huge difference in how I do statics. And I strongly recommend that you get one. You can use a vanilla scientific calculator to do statics. I mean, that's how I learned it many, many years ago. But it changes how you do the class. And so I will focus my class around these calculators, my problem solving. I won't always show you how to do how to work a problem using a regular scientific calculator. More often than not, I'm going to show you capability on these calculators. To me, it's worth the extra cost of getting one because they're hugely helpful in statics. I strongly, strongly recommend that you get one. Many students that I teach, don't believe me at first, but afterward, within a week or so, they go like, "Oh yeah, you're right. I'm going to get one," and I strongly recommend that you do so. I guess the TI-89 is technically discontinued at this point, so you probably are limited to the nSpire unless you still have an 89, or whether you can get one used or even borrow one. But again, I strongly recommend that you get one. So here's the nSpire. So if you turn it on, the way I recommend setting it up, if you navigate down to settings here and hit enter, and go down to document settings, enter. And I like to set my number format up as to float 5 or float 6. And this gives me a long enough of a number that I can see. We carry 3 digits, but I want to be able to see 4 or 5 digits. And so this lets me see the additional digits. Angle is in degrees. There might be a few problems here and there where we use radians, like for example, belt friction problems, but for the most part, we work with degrees. Exponential format. I recommend engineering. Many of you are familiar with scientific notation, which is basically 1.33 times 10 to the 5th or 2.66 times 10 to the 3rd. But engineering is an exponential format, but the times 10 to the n is always times 10 to the 3rd, 10 to the 6th, 10 to the 9th. And so you get a real number times 10 to the 3rd or 10 to the 6th. And that's really handy because I like seeing a real number. Plus, most of our engineering units are in millimeters, kilometers, kilonewtons, meganewtons. They're in units of 10 to the 3rd. And so it's a little easier. You don't have to move decimal points like you do with regular scientific notation to be able to write an answer. And so I recommend engineering. Real, calculation mode approximate. There's a few times where you're integrating where maybe you want to see the algebraic solution, but virtually all of the problems in this class, we want to see a real number as an answer. And so approximate is what I recommend. Computer algebra system mode on, and we basically go, okay, vector format, rectangular. So if you look at the vector format, rectangular, cylindrical, or spherical. All 3 of those are going to be important here in these early units on vectors. These are the default display modes on the calculator. So however you enter the vector, once you hit enter, it will display using these coordinate systems. In general, you want to just leave your default display mode as rectangular. So we will enter vectors like in 2D in polar form, or in 3D, we might enter vectors in however they're given, for example, in spherical form. But once you hit enter, then it displays it in your default display mode. And for the most part, we want to keep that as rectangular anyway. If you want to convert from one mode to the other, there's functions that let you do that. But for the most part, we'll keep that in rectangular as our default display. Enter. Decimal is fine. And SI unit system, I don't really use units on it. Okay. So these are basically the default settings for the TI nSpire. And we'll just hit enter, okay? For the 89, just quickly, if you turn it on, if you go to mode, you get to its settings, and I pretty much do the same. Angle is degrees, exponential format is engineering, vector format, the default is rectangular, and you have the same two choices, cylindrical or spherical. And we'll just leave it in rectangular for our default display mode. If we go to F2, that takes us to the next page, and then takes us to the exact or approximate, and I keep it on approximate because, again, I want real numbers as my answers. So those are the default display modes on the 89. Coming back to the nSpire, some other functions that are useful to you. So if we come up here to a document, whoops. If we come up here to a document. So to enter a vector. So basically, if you have a Cartesian vector that's let's say 2010, 20 in the X and 10 in the J. So basically you go control, the square bracket, 20, comma, 10, enter. And so that's a Cartesian vector. If you have two Cartesian vectors that you're adding, you can basically take that guy plus another Cartesian vector, and this is 30, comma, 15, enter. And the sum of those two basically gives you 50 and 25. Another common way of seeing vectors is in polar form. And so you might have a vector here that's 50 newtons at 35 degrees. And so if you're given it in polar form, you can enter it in polar form. So you can go control, square bracket, 50, comma, you need an angle symbol. And so you've got these symbols here above this book. So you control, angle symbol, and the angle symbol is there, enter, and 35 degrees. Now notice I'm entering this as a polar vector. But when I hit enter, it's going to automatically convert it to rectangular components because that's my default display mode. And so once you hit enter, it converts it to polar, or converts it to rectangular or Cartesian. If you ever enter a Cartesian vector, so if we go control, square bracket, 45, comma, 35, enter, and it's Cartesian, and you say, you know what, I want to see that in its magnitude and its angle. And so you can actually go to find that there's a polar conversion function. And so if you hit this catalog here, catalog takes you to all of the built-in functions, and we're looking for polar. And so if you press P, it will scroll down to the functions that begin with the letter P, and then we can just scroll down, and we're looking for a triangle times polar. So triangle times polar, enter, enter, and that converted this 4535 to a polar form, which is 57 at an angle of 37.9 degrees. And so it's a very quick way of getting the magnitude and the angle of a Cartesian vector. And if I want to take that back to rectangular again, then you could actually go to your functions and you go to R and then scroll down to triangle rectangular, enter, enter. And that'll take, if you have a vector displayed in polar form, and this will take you back to the rectangular components. Super easy. The way angles work on the calculator, basically you've got positive theta and negative theta. And this is positive x. So basically if we have a vector over here, which is basically 40 degrees from the negative x-axis, and this is 100 pounds. I'm going to enter him as 100 comma angle, but I have to enter this angle here, and so that's a positive 140. If I have a vector down here, that's basically 30 degrees from the negative y, and if he's 200 newtons, then he gets entered as 200 comma angle, and this is minus 120, minus 120. You could also enter him as 180 plus 60 is 240. So you could also enter him as 200 angle 240. And that's the same vector. A vector down here, it's basically 40 degrees from the negative y-axis, and if he's 150 kilonewtons, then this is negative 50 degrees. So that's 150 comma angle negative 50 degrees. Many vectors are given in polar form, and so this is the calculator lets you enter it directly that way. Whereas you remember a vanilla calculator, you basically have to take this guy and you do 50 cosine 35 as the x component and 50 sine 35 as the y component and let you enter them, which is fine, but you have to do all that work. Whereas the calculator lets you enter the vector in exactly the format that is given. Some other vector functions that are helpful. Let me brighten that up a little bit. Okay, so a few other vector functions that are helpful is norm. So if you have a vector that's, let's say it's a 70, 30 vector, 7 in the I and 30 in the j, and you want the norm of this guy. In other words, you want the square root of 70 squared plus 30 squared, which is the length of the actual vector. So rather than square root of that, just basically go to the norm function. And so if you hit the catalog, it takes you to the catalog of functions. Click N, which will take you to all the functions that begin with N, and then scroll down to norm, square bracket, 70, comma, 30, enter. And so that gives you the length of the vector 76.16, and that's the diagonal. So that's the, if you've got 70 and 30, that diagonal is 76.16. So norm is handy. If we're adding vectors, so again, this is super handy. I can just enter all of these in polar form and add them. So I can basically go like control square bracket 100, comma, angle symbol 140 plus square bracket 200, comma, angle symbol minus 120. And then you keep adding vector and enter. And it'll display this. This is a minus 176, minus 109. And that's in rectangular form. And again, if you want to see that guy in polar form, then you basically go catalog P for polar functions, come down here, and that'll give you it in polar. So the minus 176.6 minus 108.9 is 207.5 at minus 148 degrees. Is polar form. And so these are some basics on how to set up your TI nSpire, how to enter vectors, how to add vectors, how to use the norm function. And we'll work a number of example problems where we'll use more of these guys as well, and I'll introduce some other functions to you as we go. But this will get you started. And again, I strongly encourage you to get an nSpire or get a TI-89, because again, these calculators let you enter the vectors in whatever format they're given, manipulate them, convert them to a different form, and it's hugely helpful. I strongly recommend it.